Hey everyone, welcome to this explainer. So today we're diving into a literally monumental breakthrough by engineers at NASA's Jet Propulsion Lab. We're going to look at exactly how they just shattered a massive aerodynamic barrier to completely unlock the future of exploring Mars. If you follow space exploration, you already know that flying on another world is tough, but what they just pulled off in the lab is absolutely incredible. All right, here's our flight plan for today. We're going to look at the legacy of ingenuity, tackle the Martian physics problem, talk about breaking the sound barrier, and then wrap up with the Skyfall mission. Section 1, Legacy of Ingenuity, the first pioneer. To really get why this new breakthrough is such a big deal, we've got to look back at where it all started. Ingenuity absolutely proved we could fly on another world, and it was a massive success. 72 total flights. The original goal was just 5 flights in a 30-day window. But it was tiny, kind of the size of a tissue box, weighing just 4 pounds. Because of that, it could only carry 2 little caras and travel less than a half-mile per hop. It proved a concept, sure, but for heavy-duty science, we've got to go way bigger. Which brings us to Section 2, the Martian physics problem, flying in a 1% atmosphere. Here's the massive roadblock. Think about a standard passenger helicopter here on Earth. The rotors spin at roughly 270 revolutions per minute in our nice thick air. But Mars, the atmosphere there is ridiculously thin, literally just 1% as dense as the air at sea level here on Earth. So to get any lift at all, Ingenuity had to spin its blades at 2,700 RPM. That is 10 times faster than a helicopter on Earth. And that brings up a huge issue, the speed of sound. On Mars, Mach 1 is about 540 miles per hour. Engineers intentionally kept Ingenuity's carbon fiber blade tips down around Mach 0.7. Why? Because they were absolutely terrified of the extreme aerodynamic stress. If they pushed it too far and suddenly hit a random Martian headwind, those rotors could just violently shatter right there in midair. There's this quote from JPL's rotor test lead, Jaco Koras, that I just love. He said, "If Chuck Yeager were here, he'd tell you things can get squirrely around Mach 1. That completely nails the anxiety of supersonic aerodynamics. To fly the heavier next-gen helicopters, we need larger blades spinning way faster. But going faster meant risking a catastrophic mid-air explosion of carbon fiber. They had to know for sure if these rotors could actually survive going supersonic." Section 3, Breaking the Sound Barrier, the high-stakes lab test. So picture this. It's a super nerve-wracking day in November 2025 at JPL's 25-foot space simulator chamber. They're trying to mimic the Martian atmosphere, but they genuinely don't know what's going to happen when the blades cross the sound barrier. It was so risky that engineers literally lined the chamber with sheet metal to act as shrapnel shielding, just in case the blades violently ripped apart. Imagine the tension in the control room, a few yards away, right? Just waiting to see if those rotors would explode into pieces against the metal walls. Okay, let's step through the actual test sequence. First, they cranked the speed up, climbing all the way to 3,750 RPM. At that point, the blade tips are hitting Mach 0.98. They are right on the edge. Then, to really simulate the worst Martian conditions, they turned on an internal fan to actively blast the high-speed rotors with headwinds. They're intentionally forcing the blades straight into the danger zone, pushing them right past Mach 1. And no way, they didn't shatter! These slightly longer two-bladed designs planned for future missions actually held together perfectly and hit an unbelievable top speed of Mach 1.08. They literally shattered their expectations instead of their blades. NASA aerodynamicist Shanna Withrow-Mazer pointed out that they thought they'd be lucky to just hit Mach 1.05. Reaching 1.08 safely proves these next-gen blades are incredibly tough. Plus, she noted they're still digging into the data, and there might be even more thrust on the table. And the immediate payoff here is just phenomenal. Spinning these slightly longer blades at supersonic speeds actually generates a massive 30% boost in lift capability. In the world of aerospace engineering, a 30% boost, that is an absolute game changer. Section 4, the Skyfall mission, unlocking the future. So what does that 30% extra lift actually get us? Well, it completely changes what we can do. While Ingenuity was basically a scout with 2 tiny cameras, Skyfall is going to carry heavy, super sophisticated science instruments, like advanced ice sensors. Ingenuity had to stick close to the Perseverance rover for comms and rely on a small solar panel. Skyfall, It won't need a babysitting rover at all. It'll have direct-to-Earth or orbit relay comms, plus way larger batteries for some seriously extended flights. All of this incredible tech comes together in this Skyfall mission. NASA is planning to launch not one, but 3 of these advanced helicopters to Mars, possibly as soon as late 2028. And get this, they'll be hitching a ride on Space Reactor 1, SR-1, which is a nuclear-powered spacecraft. Plus, because these choppers are heavier, they'll use a totally novel landing maneuver, entering the atmosphere cocooned inside a heat shield and landing themselves right on the Martian surface. It's actually super fascinating to compare this to another upcoming mission. Before we finish up, NASA is also building a 1-ton rotorcraft called Dragonfly to fly on Saturn's moon, Titan. But ironically, flying a massive 1-ton vehicle on Titan poses way fewer aerodynamic challenges than flying a tiny helicopter on Mars. Titan's atmosphere is actually thicker than Earth's, which gives plenty of lift. Mars is just uniquely difficult because of that painfully thin 1% air we've been talking about. That's why this supersonic engineering breakthrough was absolutely crucial. So by breaking the sound barrier without breaking the hardware, these engineers have completely opened up the Martian sky. We're talking heavy-duty airborne science on another planet. It just leaves you wondering, what incredible mysteries are we going to uncover now that we can finally explore the red planet carrying heavy, advanced sensors high above the ground? Thanks so much for hanging out with me for this explainer, and I'll catch you next time.